Sketch a graph on a rectangular plane to help draw the polar graph for r equals 3 sine theta. Now, whenever I graph a polar graph for sine theta or cos theta, it has a very, very, very specific look as long as it's just sine theta or just cos theta. The number in front of it just makes that picture bigger. That's all it does. So let's kind of draw out what it's asking us to draw out. The trig version of 3 sine theta. Now, I know that 3 sine theta goes up to 3, bottoms out at -3. I know that magic happens at pi, then it repeats itself at 2 pi. It goes through stuff at pi over 2, and 3 pi over 2, yada, yada, yada. So if I were to draw this, it starts out here. At pi over 2, it peaks out at 3. At pi, it hits the x-axis again. At 3 pi over 2, it hits -3. And at 2 pi, it repeats. So, let's just draw a rough draft of what this looks like. Okay, knowing very well that I am not an artist. Those of you who've watched my videos know this. But this will help us kind of figure out what we have. Now, let's draw the dots that we have so far. Okay, this is the polar coordinate 0, 0. Okay, so basically, if I look at it this way, my y-axis is basically my r. Okay, and this is basically my theta. So this is the point 0, 0. This right here is the point 3 pi over 2. So I go to pi over 2, I draw a dot at 1, 2, 3, right there. Okay, at pi, I have 0 again. So if I were to go over to pi, I put a dot at 0 again. So it looks like, I just kind of hit that again. At 3 pi over 2, which is u, I'm at -3. So 3 pi over 2, I'm at regular 1, 2, 3, but spin it in the opposite direction, and I'm covering that dot again. So right now, and then of course 2 pi is the same as 0. That's where it repeats. So, 2 pi is 0, the same thing. There's a dot. So really, I only have 2 dots. So drawing this graph, I'm kind of out of luck. So let's kind of find some in-between areas. Okay, so if I were to put a little mark here, 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 and here, that kind of gives me those in-between areas. Like at, pi over 4 and 3 pi over 4 and 5 pi over 4 and 7 pi over 4. I could put more dots there. It looks like at pi over 4, I'm at like the 2-ish range. So even though I can't see pi over 4, I'll write it out. At pi over 4, I'm at the 2-ish range, give or take. At 3 pi over 4, I'm also at the 2-ish range because this is sinusoidal and whatever it does over here, it kind of has symmetry. So I'm at the 2-ish range there. At 5 pi over 4, which would be u, at 5 pi over 4, I'm at like the -2-ish range, which means I'd go here, but in the opposite direction, which means that dot just repeats itself. So if this is going to be 7 pi over 4, and if I were to go 7 pi over 4, which seems to be in the -2-ish range, the same exact thing happens. So what's happening here is as I start out at, so I kind of see what's happening. It's circling around. So as I start at 0, 0, and as theta increases, I get further away from the 0, 0, from the pole, until I hit 3, and then I get closer to the pole as I approach pi. So starting out at 0, 0, and spinning around this way, I can kind of put like these dots around here, and that kind of gives me an idea. Okay, and again, as I'm going from 0 to pi, I slowly go from 3 and then back to 0. So from 0 to pi, I go from 3 and back to 0. Now, from pi to 2 pi, I do the same thing, but negative. So as I go from pi to 2 pi, I go like this circle, but in the negative area. So when all is said and done, what I do is I loop around and make a circle twice. But you don't see it twice. All you see is just a nice, perfectly round circle. So whenever we have 3 sine theta, 4 cos theta, 8 sine theta, negative 20 sine theta, whatever, if it's sine theta with no frequency in front of it, we're going to have a circle. And the size of that circle is going to be based on a 3. So this goes out to 3 and it makes a sine. Cosine is going to be over here. Negative cosine is going to be over here. And negative sine is going to be over there. So a lot of problems that you would see on the AP Precalculus exam might be like, look at this guy, pick the picture that works. And you could make a trig graph and do the long way, or you could just memorize the fact that if it gives you a circle, if it gives you something that looks like this, or something that looks like this, or something that looks different, you're going to pick the circle because sine theta or cos theta, when drawn on a rectangle, or I'm sorry, on a polar plane, gets you a circle. Isn't that neat?